Now, if you pull out your calculator, what you're going to find is that you have two buttons on your calculator that are associated with logarithms. One button on your calculator has the ln on it. And remember, once again, that ln is about the natural log. And then you have another one that is log. And that log button is the common logarithm. So your calculator can calculate natural logs, and it can also calculate common logarithms, but you don't have a button for log base 7 or log base 3. So the question then becomes, what happens if I want to calculate something like the log base 3 of 21? The answer is we can always take any kind of problem and rewrite it into one of our friends that we have on the calculator. We can rewrite things in terms of natural log, and we can also rewrite things in terms of the common log. So in order to understand the change of base formula, I've written down the left-hand side. We have log base A of m. Now, I'm going to write down this change of base formula in its most general sense, but in a bit, in general, you're using natural log and log base 10, but we can do it in the most general sense for any old base. So the question becomes, how do I change this log base A into a different base? Well, what happens is you end up having a division problem, and you're going to have log base, and you choose some other base. So let's call it B. Now that log base B is going to appear in both the numerator and the denominator here. Now, the only question then is, what is the argument in the numerator? What is the argument in the denominator? The argument in the numerator is the same as the original argument, the m. And the argument in the denominator is, in fact, the original base. So it ends up being a here. So log base A of m is exactly the same as log base B of m divided by log base B of a. So with that in mind, we can do a problem like example 5a. Example 5a is asking us for a decimal approximation for log base 3 of 21. Now once again, your calculator doesn't have a log base 3 button, so what we need to do is figure out how to use one of these good friends. Now, does it matter whether I try to force this to be a log problem involving natural logs or common logs? The answer is no. So you just make a choice and go with it. On this particular problem, let's go ahead and use natural logs. So I want to rewrite this problem as a natural log problem. So using the change of base formula, I remember that I can have natural log of somebody divided by natural log of somebody. So once again, the argument of the original log goes into the numerator, and the base of the original log goes into the denominator. So this is going to be the natural log of 21 divided by the natural log of 3. So the cool thing then is that I've taken a problem that I couldn't do on my calculator, and I've now broken it down into two smaller problems that I can do on my calculator. So I can find the decimal approximation for the natural log of 21, then I can find the decimal approximation for the natural log of 3, and I can divide those two, and I'll have a decimal approximation for the log of 21. Now, you have to be kind of careful on this one, because if you type your log of 21 into your calculator and you don't think about the parentheses, you may end up having something that is happening that you're not expecting. So if I come in and I type in the natural log, many of your calculators will automatically give you an opening parenthesis. And then if you type in 21, and then you keep on going and you do that division symbol and then you keep going, what's happening on this one is that your calculator is going to say, oh, all of this is supposed to be the argument of your original log. So your calculator will automatically close the parentheses after all of this. So instead of finding the natural log of 21, and then dividing that by the natural log of 3, your calculator would do the natural log of a big old fraction, 21 divided by the natural log of 3. I don't want 21 divided by the natural log of 3 to be the argument for my natural log. So if your calculator automatically puts in a parenthesis like this for you, then you want to make sure then that you close that parenthesis so that the calculator knows exactly where you want to finish that particular logarithm. So when we come in and type this, we want to say it's the natural log of 21, then close the parenthesis to say that we're done with that natural log. Then you can come in and do the division, and then it's going to be the natural log of 3. Once again, your calculator many times will give you that parenthesis in the front for free. Then you have to close the parenthesis in the back. So make sure that you're careful about these parentheses when you're typing this into your calculator. So go ahead and try this. Go ahead and type in natural log of 21, close parenthesis, divided by natural log of 3, close parenthesis, and see what you get as a decimal approximation. So what you should find is that this is approximately 2.771. Now, on this problem, since they asked us to round to 3 decimal places, you actually need to think about that fourth. So we actually have 1, 2 out there. So if that fourth decimal place was bigger than 5, we would go ahead and round up. Because it's a 2, we're just going to leave that third as a 1. So it's going to be 2.771. Now, if that's not the answer that you got on your calculator, more likely than not, there's something wrong with how you're typing in those parentheses. So double check, make sure that you can get that. If you need to pause the video and make sure that you can get the 2.771, do that now. So now that we have that, then let's go ahead and try part B. Definitely there is not a square root of 5 in terms of log buttons on your calculator, so let's use the change of base formula problem to do this. Now on part A, I pretty much randomly chose to use the natural log, so this time let's go ahead and try the other one. I can go ahead and use the common log button just as easily as I did the natural log. So let's go ahead and use this common log for this problem. So once again, I'm going to rewrite this using the change of base formulas, which means I'm going to have a log in the numerator and a log in the denominator. Who's going to be in the numerator with that log? It's going to be the argument 8. And who's going to be in the denominator? The original base of square root of 5. So now I want to do log base 10 of 8 divided by log base 10 of square root of 5. Again, be careful with your parentheses when you type this into your calculator. So when we approximate this to 3 decimal places, we should end up getting 2.584. Now once again, on this particular problem, the fourth digit was less than 5, which means we're just going to leave that third digit alone. So one more time, it's 2.584. Now at this point, you might be wondering, well, could I have used the common log up here? The answer is sure. We could have done common log of 21 divided by the common log of 3, and we would have gotten exactly the same answer. Or you might be wondering, could I do natural log on this one? Sure. We would have natural log of 8 divided by the natural log of square root of 5. We would have gotten exactly the same answer. But as you think about what I'm saying here, whoever's in the numerator, we have to have exactly the same log in the denominator. So if you choose natural log, it needs to be natural log in both the numerator and the denominator. Or if you choose the common log, that has to be what you're using in both the numerator and the denominator. As long as you use the same base for your logarithm in both the numerator and the denominator, you'll always get the same answer. So yes, you could use common log up here, or you could use natural log here, and you would get exactly the same answers.